In 2022, the Oskar Fischer Prize initiated a massive natural experiment in scientific sociology. They asked 151 independent investigators to generate mechanistic hypotheses for Alzheimer's disease with one explicit condition. They required no prior commitment to the dominant consensus in the field. These researchers operated under strict isolation. They worked at different global institutions, studied entirely different model systems, and communicated using separate scientific vocabularies. There was no coordination. Yet the synthesis report found an anomaly. 25 of 30 researchers converged on the exact same downstream node, the failure of the VATPase proton pump and lysosomal collapse. Significantly, they hit that exact node following 7 completely distinct upstream triggers. In the bibliometric record, uncoordinated convergence of this magnitude has a specific meaning. When disconnected groups independently reach the exact same target without a shared citation network, it indicates a genuine biological signal rather than an artifact of groupthink. The biological data was so overwhelming that it forced independent outsiders to the exact same conclusion. The mainstream establishment entirely missed it. This convergence points directly to what is now known as the collapse trilogy thesis. It is a biological model that integrates bioenergetic vulnerability, homeostatic glial failure, and synaptic erosion into a single cohesive mechanism for Alzheimer's disease. The historical paradox of this thesis is its age. Every individual component required to assemble this tripartite model had already been described in the published scientific literature by the mid-1980s. Researchers like Suzuki and Terry documented the ultrastructure of lysosomal accumulation in the late 1960s. By the early 1980s, stereological data clearly proved catastrophic depletion in the locus coeruleus. The raw data required to build a comprehensive framework was sitting in the library by 1985. The field did not assemble that framework until 2025, a strict 40-year temporal gap. We can definitively rule out technological limitations. The delay was not caused by a lack of sequencing power, advanced microscopy, or raw data. The delay was an institutional failure. For 70 years, Alzheimer's research was trapped in an epistemic silo, dictated by funding algorithms and citation conventions, proving that the obstacle to a cure was sociological, not scientific. To understand how the field stalled, we must look at a specific inflection point: the April 1992 publication of the amyloid cascade hypothesis. The programmatic appeal of this hypothesis was immense. It offered exactly what the scientific community wanted: a single causal mechanism centered on amyloid beta deposition and a single, highly marketable therapeutic target. The cascade hypothesis functioned as a citation gravity well. It reorganized the entire epistemic landscape of neurodegeneration, pulling funding, prestige, journal pages, and fresh trainees into one explanatory frame. The material manifestation of this gravity well was a massive funding capture. Between 1998 and 2018, NIH requests for applications explicitly named amyloid targets, absorbing an order of magnitude more money than any alternative biological mechanism. This created an equilibrium dynamic often critiqued as the amyloid mafia. Peer review networks recursively privileged within paradigm work. Submissions extending the cascade encounter elevated acceptance rates, while alternative mechanisms were systematically suffocated by a small, tightly cited community evaluating its own proposals. The ultimate consequence of this institutional monopoly played out where the stakes are highest: human clinical trials. Between 2002 and 2020, the pharmaceutical industry executed a sequence of high-powered, multi-billion-dollar Phase 3 clinical trials: bapineuzumab, solanezumab, crenezumab, and others, targeting amyloid directly. In a Popperian framework, the outcome of these trials constitutes falsification. Despite frequently hitting their biomarker targets and clearing amyloid plaques, these drugs consistently failed their primary clinical endpoints to halt cognitive decline. The scientific response to 6 independent Phase 3 failures was not to question the central premise. Instead, the field endlessly refined the cascade, pursuing earlier interventions and different specific epitopes. The institutional architecture rendered the amyloid hypothesis practically unfalsifiable. Contrary evidence was repeatedly ignored to protect a deeply established funding equilibrium. While the amyloid gravity well consumed the center, the remaining alternative research formed an epistemic archipelago. These were isolated scientific islands, operating completely independently of the mainstream, rather than a unified scientific continent. The first island was the noradrenergic silo, which focused heavily on the locus ceruleus and its extreme vulnerability to neurodegeneration. In 2011, stereological data published by Brock and Del Tredici proved that the earliest identifiable tau pathology actually begins in the brainstem, long before any cortical involvement. That single paper should have ended the field's obsession with the hippocampus. It failed to reorganize the field because it was written in a neuroanatomical dialect. Cascade-trained cortical biologists simply lacked the training pathways to read and integrate brainstem data. The second island was the glial silo. For most of the late 20th century, microglial biology was developed almost entirely by immunologists, not neurologists. When major discoveries regarding microglial risk genes like TREM2 erupted in 2013, mainstream Alzheimer's trials lacked the translational channels to utilize the data. The trials were already designed around amyloid, leaving microglial markers entirely unmeasured. The third island was the matrix silo. The study of perineuronal nets, extracellular structures protecting mature synaptic connections, was isolated entirely within developmental visual plasticity literature. This grid maps citation overlap between communities from the Fischer corpus. Deeply shaded diagonal cells represent high internal coherence. Look at the off-diagonal cells. Showing merely 9 to 21% overlap, these disciplines almost never co-authored, attended the same conferences, or cited each other. The biological substrate required to cure the disease was fully mapped out across these three islands, but the institutional bridges required to connect those maps simply did not exist. This brings us back to the uncoordinated convergence of the Fisher Prize. The entrants identified 7 distinct upstream triggers: bioenergetic, lipid, calcium, infectious, environmental, immune, and genetic. Each trigger represents a completely different subdiscipline with distinct models, and each dictates a uniquely different therapeutic strategy, from BMAA detoxification to antiviral therapies. Yet the mechanistic reality is undeniable. Despite their differing origins, they logically force the exact same downstream event: catastrophic failure of the VATPase proton pump. To understand why this matters, we must compare false convergences to real convergences in science. False convergences are artifacts of citation cascades. A few influential papers establish a frame. Downstream investigators inherit that frame to secure funding, and the consensus propagates as a sociological artifact. Real convergences happen when investigators with non-overlapping training arrive at the exact same conclusion by a completely different biological routes. They converge because the biology forces them to, not because they read each other's papers. The uncoordinated convergence of these 7 triggers proves the multi-stream biological signal was always real. It was simply suppressed by the architecture of the silos. Let's run a counterfactual. Assume that cross-silo dialogue, joint study sections, and mechanism-agnostic funding had been institutionalized by 1995. Under that scenario, utilizing data that was already published, a multi-mechanism clinical framework targeting bioenergetic and homeostatic failure could have been active by 2010. This chart maps global Alzheimer's prevalence from 2005 to 2025. By calculating a 1-year clinical delay per affected individual, we quantify the exact cost of the citation gravity well. This institutional failure results in 25 million person-years of avoidable dementia. The common defense in academia is that science simply takes time. The bibliometric record rejects that defense. The field had the literature. The cost of not having the institutions to assemble it was paid in human suffering. Disciplinary silos are not natural accidents of scientific complexity. They are the designed outcomes of our current funding incentives and peer review algorithms. We can dismantle them. The first required reform is writing mechanism-agnostic requests for applications. Funding must stipulate clinical endpoints, not specific biological pathways. This shifts the evaluative criterion from asking, "Does this fit the cascade?" to "Does this actually slow the disease?" The second reform is mandating cross-silo reviewer pools. By ensuring at least 1/3 of reviewers are drawn from outside a paradigm's specific citation network, we permanently break the peer review monopolies of dominant hypotheses. Finally, we must build open synthesis platforms. curated, machine-readable repositories of mechanistic hypotheses. This shifts the burden of cross-disciplinary integration away from individual heroic researchers and places it onto the institutions themselves. The Fisher Prize corpus proves that the biological answers are already waiting to be assembled. Solving the silo problem across all fields of disease research simply requires deliberately designing the institutions that make synthesis routine.